A weight is attached to a spring that is hung from a board, as pictured here on the left. As the spring oscillates up and down, the position y of the weight relative to the board ranges from -3 inches at time x equals 0 to -10 inches at x equals pi below the board. Assume the position of y is given as a sinusoidal function of x. Sketch a graph of the function, and then find a cosine function that gives the position y in terms of x. Let's begin by plotting several points on the graph. At x equals 0, the position is y equals -3, which indicates the graph contains the point 0, -3, the y-intercept. The position is -10 at x equals pi, which indicates the graph contains the point pi, -10, which is this point here. We now know the max is y equals -3, and the min is y equals -10. And because the spring is oscillating up and down, we know at 2 pi, the position is y equals -3. At 3 pi, the position is back down at y equals -10. Let's go ahead and sketch the sinusoidal graph that resembles the cosine function. And now let's begin to gather some information about the graph before we write the equation. Notice the period is 2 pi radians. Notice from x equals 0 to x equals 2 pi, the graph makes one complete cycle. And next, let's determine the midline, which is the horizontal line halfway between the max and the min of y equals -3 and y equals -10, which is going to be y equals -6.5, this horizontal line here. If you're wondering how I got -6.5, I took the max of -3, added the min of -10, and divided by 2, which does give -6.5. Also notice there is no horizontal shift or reflection across the midline, because starting at x equals 0, we have the pattern of the basic cosine function of max, midline, min, midline, max. And now let's build the equation for the cosine function, referring to the form y equals a times cosine of b times the quantity x minus c plus d. Because the period is 2 pi, and 2 pi divided by b equals a period, b is equal to 1. And because there is no horizontal shift or phase shift, c is equal to 0, which brings us to the form y equals a times cosine x plus d. The value of d indicates a vertical shift, which we do have, because the midline is y equals -6.5. The cosine function has been shifted down 6.5 units, which indicates d equals -6.5. And now we'll determine the value of a. Recall the absolute value of a is equal to the amplitude, and if a is negative, we have a reflection across the midline. Well, we know we don't have a reflection across the midline, again, because the pattern starting at x equals 0 is max midline, min midline max. The distance from y equals -6.5 to y equals -3, or the distance from y equals -6.5 to y equals -10, is 3.5 units, which indicates a equals 3.5. We now know the cosine function that gives the position y in terms of x is y equals 3.5 times cosine of x minus 6.5. I hope you found this helpful.